find the general solution for the differential equation over here. Now that the exam is CBT, computer based, you should be able to download the handbook and get used to actually looking at it from your computer, since now everything is done online. So because before I had the book and I was flipping through the pages, but now I downloaded it just so we can have that experience of kind of like a computer based type of thing. Okay, so that's why I downloaded it here. So I go straight to the page. It's very search friendly, so you just type up whatever it is that you're dealing with. So I just typed in differential and it brought me to this page. So now the question here, this is a second order differential equation. You had the second order, so I'm gonna have to rewrite this into this particular form so that I look at if I have a squared, if it's greater than 4b, to see what the solution, what the form of the solution is supposed to be. Okay, so now I'm gonna have to rewrite this in that form of r's and stuff like that. So I have r squared plus 2r plus 2 is equal to 0. Now my a is 2 and my b is 2. I have to write that because otherwise you can mix that up with thinking that a is 1 over here. I've done that before because I'm super used to equations being ax squared plus by, you know what I mean? But in this case your a is actually 2 and your b is over here, right here. So it's r squared plus ar plus b. So my a is 2, write that down, and my b is also equal to 2. Okay, so now of course a squared is 4 and 4b is 8. 4b is 8, and of course a squared is less than 4b, and therefore I'm dealing with this one over here. I wish I could write on this, but I hope you could see where I'm pointing out. So my form is gonna be y is equal to e alpha x c1 cos etc etc, and my alpha is minus a half, and beta is this. Okay, so let's go ahead and do that. So let's write down the form. So y is e alpha x c1 cosine of beta x plus c2. Now in this case they're not asking us for they just want to find this general solution, not the particular solution. So this one is pretty straightforward. They're not even asking us for the the constant, because there's no initial condition that was given. Okay, alright, so my alpha is minus a over 2, so that's minus 1. My beta is, now here be careful here too, because your square root is just on the top. I've made that mistake before as well, where I've calculated beta and took the whole square root and ended up with a completely different answer. And I could tell that I may have get it right, may not, you know what I mean? Because of my alpha, that's kind of sort of saved me, but I didn't get the beta right. And I was wondering if I get the answer right or wrong, you know what I mean? I ended up guessing because of my my alpha. But sometimes if all they give you is the same alpha, then what are you gonna do? You know what I mean? So you have to be careful here that the square root is only for the top. That's kind of primary, elementary, but be careful. So these kind of things can kind of mess you up a little bit. So that's what is it again? 4b minus a squared. So only take the square root upstairs, I mean on the numerator. So that will be 8 minus 4 over 2. So that's a 2. I mean that's a 1. right? 8 minus 4, 4. Square root of 4 is 2, 2 over 2 is 1. So my form, final form, let me put it in yellow, is going to be e to the power minus x or t or whatever, x c cosine of x plus c2 sine of x. That's it. Now finding general solutions are that's not too bad, only when you have to find the constants where they give you initial conditions, or you have to find a particular solution, CP. That's when it gets a little tricky. Other than that, it's fairly straightforward. Just go to your handbook and then pick whatever you have to pick, and that's pretty much it. Okay.